How round is round enough? Over the years, mankind has developed a variety of products used to benefit our daily lives. These types of products are often used for transportation, recreation, industrial, and consumer goods. All of these products have components with circular shapes. One common example of a circular shape is the wheel. The wheel is part of one of the simple machines found in nearly all products today. The wheel was invented in the Stone Age, but a Stone Age wheel wasn't an exact circle. Today, wheels and other circular shapes are a part of our everyday lives. They're used in many different types of products. Without them, many products would not function very well. But even with sophisticated manufacturing processes, producing perfectly circular shapes on parts is impractical and expensive. But how round is round enough? How out of round can a shape be before it affects the function of a product? In describing roundness imperfections, the term roundness deviation is often used. Roundness deviation is the amount a circular element can deviate from a perfect circle. Here is an example of roundness deviation. Here are a few extreme examples of products with components that are out of round. In each of these products, the roundness deviation impacts their function. In some cases, the product still functions, but not very well. In other cases, the product just fails. Objects with circular elements, such as wheels, gears, balls, and other circular shapes, don't have to be perfectly round, but they do have to be round enough to function as intended. The best way to communicate the allowable roundness deviation for circular shapes is to use a geometric tolerance, such as the circularity tolerance. The circularity tolerance shown here is from the ASME Y14.5 standard on dimensioning and tolerancing. The drawing shown is dimensioned with a size tolerance. The allowable roundness deviation for this part is based on the value of the size tolerance. This part is similar, but with the addition of a circularity tolerance. The circularity tolerance limits the roundness deviation to a smaller tolerance zone. The tolerance zone size is based on the function of the part. So, to answer the question of how round is round enough, we need to consider the part function to determine the roundness requirement. For example, not all parts need a circularity tolerance. Parts with circular shapes, like a doorknob, cup, or washers, don't require a circularity tolerance because the roundness deviation defined by the size dimension meets the requirement for the function of the part. However, parts with circular shapes may require a circularity tolerance because the function of certain diameters may require the roundness deviation to be less than what is allowed by the size tolerance. This presentation is only an introduction to the topic of roundness deviation. For more information on the circularity tolerance, refer to the following sources: the ASME Y14.5-2009 standard on dimensioning and tolerancing, the Fundamentals of Geometric Dimensioning and Tolerancing Using Critical Thinking Skills textbook, and the Ultimate GD&T Pocket Guide, both written by Alex Krulikowski. All of these products are available at etinews.com.